In this problem, we're going to prove for any given n integers, a1, a2, up to an, we can find a subset of these numbers so that the sum of the subset is a multiple of n. You can pause the video, try to prove it. Now here we're going to use Pigeon Hole Principle for the proof, which states if you have n objects, you try to put them into m containers where n is greater. We claim that at least one container would have contained more than one object. So for example, if you try to put 10 pigeons into 9 holes, there's going to be one hole at least contain 2 or more pigeons. In this case, 2 in the first cell. Alright, so original problem, if n is 1, I have only one integer, of course 1 divides that integer, so that's trivial case. Now when n is greater than 1, we consider what is called subset sum. Okay, so S1 is the sum of the first number, S2 the sum of the first 2 numbers, S3 sum of first 3 numbers, so on and so forth, and Sn. So you have n numbers. Now, if you're lucky and you already find a multiple of n among those numbers, then you're done. Case 1 is the case where there is some Si is already multiple of n, we're done. We found the subset sum. If not, in the second case, that is, none of these numbers are multiple of n. In other words, when divided by n, the remainder is going to be non-zero. It's going to be 1, 2, up to n minus 1. So in case 2, we have this Si, n numbers, but we only have n minus 1 remainders values, right? So Pigeon-Hole Principle tells us that at least 2 numbers here share the same remainder. In other words, there exist I and j not equal to each other, so that Si and j are congruent mod n. Okay, this by the Pigeon-Hole Principle. So what that means is that if the 2 numbers are congruent, then the difference is going to be multiple of n. So we have n divides the difference of Sj minus Si. Here we notice that j is greater than I. So what is that? That is just the sum of I plus 1 up to aj. So we have shown in the second case that we can find a subset so that the sum is a multiple of n. Now here, for example, S3 minus S1, you would start from A2 plus A3, right? So here we have found a subset that is a multiple of n. So we have just proven the statement that for any given n integers, we can find a subset of numbers so that the sum is a multiple of n. Alright? So that's the proof. Please like and share.